dual nature of light and matter. Photon. Photon is the particle of light which travels with the speed equal to speed of light. It is a neutral particle whose spin is 0. Energy of single photon is given by hf, where f is the frequency of radiation and h is the Planck's constant, whose value is 6.63 into 10 power minus 34 joule second or 4.14 into 10 power minus 15 electron volt second. Also, speed of light c is given by lambda into f, where lambda is the wavelength of radiation and c is the speed of radiation. Energy of single photon is also given by hc by lambda, or which mathematically simplifies to 12,400 electron volt angstrom divided by lambda in angstrom. Momentum of photon is given by P equal to E by C, which is equal to h by lambda. Rest mass of photon is 0. Hence, energy of photon is purely in the form of kinetic energy. Gravitational mass of a photon is given by hf by c square, which is also equal to E by c square. E is energy of a photon. Number of photon per second is denoted by photon count, and its value is given by power of the source divided by energy of single photon. Its value is P lambda by hc. Now, let's talk about photon flux. Number of photon per second per unit area is photon flux. Phi ph is equal to intensity of radiation divided by energy of a single photon. It's given by I lambda by hc. Photon density is number of photons per unit volume, which is given by phi by c. When electric field wave E equal to E naught sin omega t minus kx is given, then energy of photon related to this field is given by h cross omega, where h cross is h upon 2 pi and its value is 0.66 into 10 power minus 34 electron volt second. Force exerted on a surface due to radiation. When photons fall on a surface, they exert a force and pressure on the surface. The force or a pressure experienced by the surface exposed to the radiation is known as radiation force or radiation pressure. Radiation pressure is given by I by C cos square theta into 1 plus R. I is intensity of incident radiation, C is speed of light, theta is angle made by incident beam with normal to the surface, R is reflectivity of the surface. Note that sum of reflectivity and absorptivity is unity. Now the next topic is relativistic mechanics. When we talk about non-relativistic mechanics, idea is when the speed of the particle is very less than speed of the light, the mass of the particle is practically constant, which is called its rest mass. But when we talk about particle whose speed is comparable with the speed of light, mass of the particle changes, which is not equal to its rest mass, but it is increased. Hence, to conclude this, the mass of any particle is said to be dependent of its speed. Let m naught be the rest mass of the particle, then the mass of moving particle is given by m equal to gamma m naught, where gamma is Lorentz factor, which is given by 1 upon under root 1 minus v square by c square, where v is the speed of particle. Also, the energy of any particle is given by E equal to square root of m naught c square whole square plus pc square, where p is the momentum of the particle. Also, rest mass energy of any particle is given by E equal to m naught c square, where m naught is its rest mass. Now the next topic is photoelectric effect. When radiation is incident on a metal surface, then electron emission takes place. This emission is known as photoelectric effect. Firstly, we will discuss about why the wave model of light failed to explain photoelectric effect. First is frequency problem. According to wave model of light, photoelectron emission should take place at every given frequency of radiation incident, but electrons do not come out for every frequency incident. Second is time delay problem. According to wave model, electrons should come out after some time, but electrons came out almost instantaneously in about 1 nanosecond. Third is intensity problem. In wave model, intensity is proportional to amplitude, but when intensity is increased, electric field should increase, so the electrostatic force should also increase. Hence, kinetic energy should increase, but the problem was kinetic energy remained about almost constant. These all problems led scientists to the theory of dual nature of light. Hence, we conclude that light has both wave and particle nature, but at a single time, one of its nature is absorbed. Now let's discuss about the work function. Work function is the minimum energy required for electron emission. According to Einstein, maximum possible kinetic energy of ejected photoelectron is given by Ke max equal to energy of incident photon minus work function of the metal. Threshold frequency and threshold wavelength are the frequency and wavelength at which the kinetic energy of photoelectron is 0. ID is the limiting scenario. For electron emission, frequency of radiation should be greater than threshold frequency, and wavelength of radiation should be less than the threshold wavelength. In photoelectric experiment, an electrical circuit is set up in which radiation are incident on emitter plate, which is negatively charged, and emitted photoelectrons are attracted by positively charged collector plate. In this experiment, the ejected photoelectrons travel to collector plate from emitter plate, through which its speed increases, hence kinetic energy increases. Particularly, the maximum kinetic energy in the experiment is given by kinetic energy max equal to energy of photon minus work function plus E delta V, where delta V is the potential difference between the collector and emitter plate, and E is the fundamental charge of a particle, whose value is 1.602 into 10 power minus 19 coulomb. When we apply negative potential between collector and emitter plate, at potential equal to stopping potential, emission of photoelectron stops and the photoelectrons are accumulated on the surface of emitter plate. The stopping potential is given by V equal to kinetic energy max of ejected photoelectron divided by E, or energy of photon incident minus work function divided by E. Also note that stopping potential is a positive quantity. Here are some conclusions of this experiment. First, when external potential is applied and increased continuously, after a point there is negligible change in the photocurrent, which is called saturation current. Second, slope of potential difference versus frequency curve gives the value of h upon E. Third, slope of potential difference versus 1 upon lambda curve gives the value of hc by E. Fourth, saturation current is directly proportional to intensity of radiation and it doesn't depend on frequency of incident radiation, and it is the maximum photocurrent for given intensity. Fifth, stopping potential only depends on frequency of incident radiation and is independent of intensity of radiation. Now let's discuss about quantum efficiency. It is the ratio of number of photoelectrons emitted to the number of photons incident and is denoted by Greek letter eta. Saturation current, when radiation of power P having wavelength lambda and photon quantum efficiency eta, is given by Is equal to eta E P lambda by hc. Wave nature of matter. By using symmetry argument, de Broglie defined for a moving particles wavelength lambda is equal to h upon p, where p is its momentum, which is further simplified as lambda is equal to h upon mv, lambda is equal to h upon root 2 mke. When a charged particle having a charge q is accelerated by potential difference delta v, its de Broglie wavelength is given by lambda is equal to h upon square root of 2 mq delta v. For gas molecules, de Broglie wavelength is given by lambda is equal to h upon mvrms, where vrms is root 3 rt by m0, which is root mean square velocity of gas. Heisenberg's uncertainty principle. The matter wave picture given by de Broglie elegantly incorporates the Heisenberg uncertainty principle. According to this principle, it is not possible to measure both the position and momentum of a subatomic particle at the same time exactly. The product of uncertainty in position delta x and the uncertainty in momentum delta p is never less than h upon 4 pi. ID is delta x into delta p is always greater than h upon 4 pi. It must be noted that uncertainties in x and p are not due to imperfections in apparatus. In fact, they are due to the fact that quantities involved x and p are not precise.